So I made a list of all of the stuff that should have been completed by Monday night at midnight. So you see all that? It's not quite all done because I don't know if you... Yeah, And then we had this kind of stuff going on as well. And the question comes up, well, if I didn't get it all done by then, am I going to face a penalty? And the answer is no, you're not. So you just need to get her done. If next week this time you're still missing this kind of stuff, then you'll have issues. And then later today I'll be posting things. You see that Weaver student right there? That is what you can use if you're not able to get into Blackboard elsewise. That's a dummy account I've set up. And you could even peek at Physics 112 while you're there, just to see what that's like. That we spent time today working with position versus time graphs and moving in front of them. And I had a chance to get into my rant about greater than or less than and how you shouldn't use that terminology. That those symbols indicate directions on number lines, not greater or lesser, which of course would be a magnitude kind of issue. Furthermore, greater and lesser, that they don't even match each other, because when you're talking about greater, you're talking about in terms of counting numbers. That in math world they talk about integers versus real numbers, because more or less is the way you would describe real numbers. Greater and fewer is what you would use to describe integers. And so even having greater than less than doesn't make sense because you are using the English wrong. I reminded you about this slope-intercept form to describe a line, and then we spent some time talking about where that kind of comes from. And so we talked about slope, and then we know the slope of the position versus time graph gives us the velocity. And so the rise over the run in that case is r or x or y or z or p or whatever in the heck you want to use to describe something's location. And then we did a little bit of algebra, and then I showed the form. And so that y equals mx plus b in physics land is the final position equals the initial position plus velocity times time. And then we spent some time looking at how to try to match our motion to graphs and using language that I always will say, are you moving towards or away? Are you speeding up, slowing down, or staying the same? So this is all describing constant motion. Then I had you try to match this sort of motion, which is both are moving away, but in the case of A, you're slowing down. In the case of B, you're speeding up. And then I described that there are 7 possible types of motion. The standing still, which is kind of a motion, moving away at a constant rate, moving towards at a constant rate, moving away, speeding up, moving towards speeding up, moving away, slowing down, moving towards slowing down. And then the other thing we did is to try to match up position, velocity, and acceleration versus time graphs. And so here are 2 potential positions, position graphs, position versus time. And then I asked you to tell me what the velocity versus time graphs would look like that match that, and then acceleration versus time. And that's where we ended this up with me suggesting a mantra that if the acceleration is in the same direction that you're moving, you speed up, and if the acceleration is in the opposite direction of the way you're moving, you slow down. The other thing on the board is for screenshots If you have a Mac, you do Command Shift 4 and then drag around the area of interest and it's automatically saved to the desktop. If you got a PC, you do Control and Print Screen, which puts it on the computer's clipboard. So you have to go into a program like Paint and paste it and then save it as a file, and then you can put that up on your website.